Welcome to VW 2.5. Today we're going to be talking about absolute values. So to start, let's write this down in our notes. Absolute value, and that's actual box. So the box could be anything. If it's equal to A, that then implies that the box should equal A, or the box could equal negative A. And that's the basic idea of an absolute value. And of course, this is going to be for equations. And a big assumption is that A is positive, meaning it's greater than 0. So we can use that idea right here. In our first example, we're going to isolate the absolute value. It's typically what you want to do. Isolate. Because if it's isolated, we can do this idea right here. We can kind of use this property. So I'm going to move that 2 over. And I'm going to separate. So think of the box as, again, whatever is inside your absolute value. So that's our box right there. That would mean 2x minus 3 should equal 5, or 2x minus 3 should equal negative 5. We solve it. X equals 4, or x equals negative 1. We have two answers there, so I'm just going to write it there. 4, x equals 4, negative 1. And our first example is done. Let's go to a harder example. So for this one, notice how it's significantly more challenging. We have absolute value on both sides, and both sides are algebraic expressions. We're actually going to do it the exact same way. I'm going to separate it. We'll take this first part right here, and we're saying, well, this part, x squared plus 3x, must equal whatever this thing would be, x squared minus 2x. So you can think of it as, let's just leave them alone. We essentially remove the absolute values, and that's one possibility. The other possibility would be this x squared plus 3x would equal the negation of x squared minus 2x. So essentially, we're thinking of this thing right here as your box, and we're applying it the exact same way with the absolute value side over here. And now we just solve it, so let's just cross that out. We get 5x equals 0, so x must equal 0. So now let's solve the right side. We have x squared plus 3x equals negative x squared plus 2x. Let's subtract it and add it. So 2x squared plus x should equal 0. We factor out an x. 2x plus 1 should equal 0. So x should equal 0, or negative 1/2. We put it together. Our therefore is x equals 0, or negative 1/2. Now let's go to our next part. Inequalities. So inequalities, I know you learned it last year, but I want to make sure it's really clear for you. It says solve the inequality, the absolute value of x is less than 4. So if I were to just ask you to think about what answers are going to work, here's our number line. Let's say here's 0. We want all the numbers that are less than 4 if we do the absolute value. So clearly everything less than 4 to 0 should work, like 4, 3, 2, 1. All those answers are going to be fine. But also negative 4. Everything above negative 4 should also be fine. So now we can see our answer is right there, negative 4 to 4. Now if you want to think of it in words, what we can do is think of it as all numbers less than, I really highlight less than, because that's what it says right here, 4 units from the origin. Because mathematically, that is what's happening, right? Here's our origin, and everything within 4 units is counted as the answer. Now, if we try a different one, let's say right here, absolute value of x is greater than 3. Let's try it the same way. Here's our 0. Here's 3. We know everything 3 or above 3 is going to be fine. Like 3 is not going to work, but 4, 5, 6 to forever. Now think about -3. Everything under -3 should be fine. -4, -5, -6. So our answer here is going to be -infinity, -3, union 3 to infinity. Very interesting. So notice how when it's a greater than, the answer goes away, whereas less than, the answer goes inside. So if we're going to write this in words, we're going to write, this is simply all numbers more than or greater than 3 units from the origin. So algebraically, let's kind of put this in a nice, neat way. If we have the absolute value, and I'll use a red box here, of some red box is less than A, our conclusion is going to be our box is between A and -A. If we have absolute value of some box is greater than A, our conclusion is going to be the box is greater than A, or the box is less than A. So if you look at this sign right here really matters. If it's less than or greater than, the less than corresponds directly to this answer, and the greater than corresponds directly to that answer. And of course, a huge assumption here, so you really want to put a big star on your notes, is assuming A is positive. So for all this, we're assuming A is a positive number. That's important because let's look at this example. If you just mindlessly try to do the algorithm I just taught you, you'll get it wrong, because if you think about this, the absolute value of any number will never be negative. So for this one, there's no solution. So you just gotta be aware of that. Make sure you always understand what you're doing. Okay, so let's go into it. Now we have a little more complicated things. So this says the algebraic method. So essentially, we're gonna use this idea right here and really focus on this less than or greater than. So for this one, notice how it says less than or equal to. That's important because that means we're in a situation where the answers are going to be within. And the keyword is within. So we're going to grab this 2x plus 4. So that's our box. And we're saying our box, whatever this would be, should be between 3 and -3. And now we solve it. So just subtract 4 from everything. Divide by 2. And there we have it. And if you do it right, you should notice your answers should be going into each other, which they clearly are. And as an interval, we would just simply write -7/2 to -1/2. So there's our answer in 3 forms. Here's an inequality, an interval, number line. For this one, notice how it says greater than. That's important. Greater than. Because what that means is we're going to be in a situation like this one, where the answers are going to be going away like that, which means our box, our 2x plus 4, our 2x plus 4 is going to be greater than 3 in one situation, or our 2x plus 4 should be less than -3. So we solve it. 2x is less, or sorry, 2x is greater than -1, x is greater than -1/2, or we solve this side, So again, notice how that should work out, right? Because these answers are similar to over here. But that greater than changes everything. Because if I were to put a number line now, I know negative 7 over 2 is here, negative 1/2 is here. When I graph this answer, notice how if I want everything greater than negative 1/2, the answer is now going on the outside, which means our answer as an interval is going to be negative infinity, negative 7 over 2. I'm going to need more room. Union, negative 1/2 to infinity. And we'll leave our answer as an interval. That's it.